Yeah, so welcome to my workshop. I'm Oscar. I'm with the engineering team at Fedi. And fortunately, my demo didn't work out. I was just grinding this morning, trying to get it to work. But I got really close. Maybe, depending on how we want to use the time, we could just hack on it together towards the end. But the goal of this is just, go through some basics, actually, just like ecash technical basics. I feel like a lot of times you go to these technical conferences and everyone but just kind of expects that everyone understands the basics. So it might seem rudimentary, but I like going through the motions just in case, there's some people that just kind of take it for granted and they don't actually have it clear how it works. So we'll do a little bit of basics. We'll do a little bit of like kind of anatomy of an ecash note. On my end, I'm more familiar with the Fediman ecash than the cashew, but I did read up a little this morning, and so maybe we could just go through both. And then, so transmission methods, what I mean by that is, ecash is the data. So there's just any way you can transmit data, you can transmit ecash. So what I'd like to see, kind of in the ecosystem are creative ways to just transmit data, and I'll go through a few of the methods that, at least in the Fedi app, we have. And then, so basically one of these crazy ideas, let me move on a little here. So that's me. Nice to meet you all. Like I mentioned, we'll do some basics. And so basically these three ideas, the third one's just kind of for fun, but you get the idea. Copy pasting, that's familiar, but it's also, there's a lot of friction to it. Animated QR codes is kind of a new way, a newer way. It's a little more familiar. People can scan QR codes, but since you're actually dealing with quite a bit of data to fit into one QR code, if you animate it, then there's a nice kind of visual method for transmission. And then this last one is the fun one, is audio. It's like maybe we can transmit ecash over audio. Like theoretically, it's perfectly possible, and that's what I was trying to get to work on in my demo. And I couldn't quite get it there, but we'll go through the idea and just, it's a fun idea anyway. Maybe I'll present it for the hackathon if I can figure it out. And just remember, the text form is at the end of the day what we're talking about. Like the QR codes boil down into text, the audio boils down into binary ones and zeros. So ecash basics. I'm sure we've been learning through whatever talks. The money is the data. It's a bearer token. Anyone with a copy of the unspent ecash token can request a fresh token from the mint, invalidating the previous one. So I just kind of put together a little diagram visual here. Alice has a 10-sat ecash note. When she wants to send it to Bob, she copies it. So she transmits it by whatever means, copy pasting, animated QR. And then now they're put these in yellow because now it's kind of like in a race condition mode where whoever decides to go up to the mint to refresh first gets the fresh ecash notes. So after the reissuance, both of these copies are now invalid because the mint stores all spent tokens to obviously prevent future spend attempts. You can see this the little dot up there that the mint keeps track of all the spent tokens. So basics. This is what an ecash token looks like. You can obviously copy paste that. Copy pasting has a few properties. It's simple. It's just like, okay, it's text, dumb enough. Cumbersome and ugly. Like, imagine copy pasting this. There's this little video copy. Imagine sending your friend some money by doing this. Chat. Okay, go whatever, WhatsApp, Signal, whatever it is, and we're 15 seconds in already, like, paste, boring, ugly. This is not, we want to do better than this. So that's what an ecash note looks like, and so at least the Fedimint type of ecash, looks like that. The cashew ones have a little prefix and a version at the beginning. At the end of the day, we're looking at an encoded form of binary data. It's base 64 encoded, at least the Fedimint version. The cashew version is CBOR encoded, which I thought was interesting. At least the CBOR website, made a pitch for how we have JSON encoded data, and typically gets encoded into base 64. But at the end of the day, they look pretty similar. The Fedimint one has the Federation ID prefix. which the cashew counterpart would be within the JSON, you have a field for the mint URL. And then the notes of each denomination. So what I want to show here is just kind of, what is the ecash note exactly? It has a signature in there, but it also has an amount in there, not in the way you might think, like, a typical Bitcoin transaction, you might have amounts, but you got to add things up basically. And basically what I wanted to show you guys here is, at least with the Fedimint CLI, it's a little small. So yeah, there's a little command here. Actually, let me just, yeah, 1 second. Let me also make this bigger. How do I do that? Yeah, okay, let me just pop this open. Get this out, okay. So yeah, I mean, I have the Fedimint CLI built in. I just built it using Nix. And so Fedimint CLI, you can see all the different commands. There we go. So the Fedimint CLI, if you want to play with that, I highly recommend it. It's pretty fun. So here in the dev command set, we have a little decode function. So we look at that help doc. You can decode invite codes, notes, transactions. So we're going to look at notes right now. And you basically just pop in the entire note. And so this is going to show us what it looks like in JSON. Right, so as I was saying, we have the Federation ID prefix and then this notes field. And so if you look at these, the keys, right, it's the denomination is basically the amount of MSATs that you have an ecash note for. So if we add all these up, 32, 64, and you have to use, I believe, the number of elements in this array, right? So I have 132 MSAT note with a signature and a spend key. And so if let's just go ahead and do this. Plus 64, plus 256, plus 512, plus 8192.
Like DXOs.
Exactly. 32768. Each of these have one each. 0172, 262144, 104, 8576. 1.5 million MSATs, so 1,500 sats. That's what this ecash node contains. And so just to validate, let's go ahead and pop this in. I forget which federation. I think it was one of these public ones, Bitcoin Principles. So yeah, the other thing I'm going to show you guys is our source available repo. You're able to build the React Native app from that. So I highly recommend you check it out. But here, let me just join the community first. And also do this the other way around. We'll generate one from the app and then decode it. Ignore that little start listing. That was my failed demo. Did I, yeah, I must have messed something up on my, actually get some money from the faucet here. Let's just do it the other way around instead. I'm not sure why I probably busted something in my code while I was doing my demo. But if we look here, okay, got some money from the faucet. Let's generate one. Let's see, let's try to get an easy multiple here of MSATs. So let's say, this is going to be tricky. So one sat. What's the easiest way to divide by 1,000? So this is another interesting part. The client-side logic is, for any given SAT amount, we're trying to like efficiently subdivide into all these different denominations of ecash nodes, and there's a whole, logic to it. Basically, like you might already have a bunch of one denomination of nodes, and you kind of, I think the principle, someone correct me if I'm wrong, is like you kind of want a blend of everything. You don't want just two SAT nodes or two MSAT nodes. And obviously the different amounts that you make, even like you can even consider like how often or like the types, the amounts of payments that you make on a regular, like if you're doing lots of large amounts, then you might want a different type of denomination blend. So yeah, there's some nuances there that's kind of worth maybe researching a little bit, exploring more about note selection. But yeah, anyways, let's see here. So what would I do here if I wanted an even number? 32, 512. So 512, 488. I think we kind of got to go down in multiples here. 256, 128, 64, 32. Okay, so let's do 1,000. Let's try and just do, what's 1,000 minus 512? Is that what I want? 488. No, that's not what I want. I'm confusing myself. So let's just do, let's see what the algorithm does just with 1,000, right? So I kind of expect it to give me one of each of these denominations if I give it one sat. Because remember, we're talking about MSATs. And the fees are probably going to throw off everything, actually. Do we have any fees? I don't think so, hopefully. Let's check this out. So, salt bin, Fedimint CLI, dev, decode, notes. Nope. Oh, you're kidding me with the Android clipboard. There we go. All right. So, as you can see, we got one note of the ones we were expecting. 512, 256, 128, 64, oops, and 8. So you get the idea. You gotta, select the denominations that you want. So anyways, moving on a little bit. Yeah, so copy pasting, the other thing I want to mention, this is obviously the blob, the text blob that you can put into things like some of the functions in our web SDK. Validate notes. If you pipe that into validate notes, you're going to get the amount of MSATs, what we were just looking at basically. It's going to decode, it's going to count everything up, and you get the amount that notes represent. You also pass those right into the reissue external notes function, which is basically an operation, right? So Fedimint has got a lot of state machine logic. So basically the first thing you get from this function is an operation ID, which corresponds to an operation in your local database that can only have a certain number of states. It can only be in one state at a time. So obviously it starts out in like a created state, and then as those notes actually get reissued, because you might be offline, for example, you might not be able to make a request to the Federation just yet. So that operation is going to be in a particular state, depending over time on what that operation is going to do. So at the end of it, once it's finalized, you'll end up with the notes that you're looking for. And so you kind of just subscribe using that operation ID to the updates of the operation. And then once you see the finalized state, that's going to give you maybe your new set of notes, actually. We'd have to check in on that particular function. Or rather, not this function, but the subscribe function. That, and you can look up at the documentation, and that'll give you everything, all the information you need to know. So yeah, that's all on that. Any questions so far? Following along, pretty basic. Cool. So yeah, we've got this new idea here with the animated QR codes. And we can poke around the code base a little bit on how we're doing this. I actually don't think there's too much, we haven't given a lot of thought into optimizing for this. We kind of just took the whole note, split it up into even number of frames, just split the buffer up, and then we play this on loop over and over. And so as you're scanning it, depending on the quality of your camera, maybe you'll skip a frame, but it's okay because you'll come back around and get them all eventually. But user experience wise, we really want to not have people just kind of standing there. We have a little progress bar too, so it'll tell you, okay, 1%, 2%, 10%, and it depends on the number of notes too. If I have a perfectly divisible multiple of the denominations, it's going to be pretty short because it might be just 1 or 2 notes. But yeah, just depending on that, you're going to get a longer loop of frames here. So yeah, there might be creative ways to optimize for that. You might be able to think of it, you have device, receiver, and sender. So the sender is displaying the QR code, the receiver scanning, and you might even be able to establish some kind of out-of-band communication, or maybe even directly in the visual somehow. But so you basically want the receiver to try and tell the sender that I already have these frames. And so the sender can start to just remove the frames that you already got, so we get fewer loops. And that might cut down on the actual time it takes to complete the transfer. So yeah, again, very basic. This is one of the things we have in the Fedi app, this animated QR code. And so, yeah, that's familiar to people. I mean, the only thing I've seen is people are like, oh, wait, why is that QR code moving? But they don't have any trouble realizing that they have to scan it. So, yeah, it's a little more efficient. And, yeah, user-friendly. So.
Is it using the same one as maybe, I don't know, Cashew and other, like you're using the same library?
Yeah, let's check it out a bit. Let's take a little detour on the presentation, or rather the slideshow. But yeah, so here, this is that open source repo I was talking about, all my non-functional demo code. But yeah, so let's see, where's that file? Animated QR code scanner, not the legacy one. Let's find where this is. Get that here. Okay, QR code scanner. Let's check this component out. And no, it's not the scanner. Yeah, well, the scanner scans the frames, if I remember. Okay, yeah, here we have some logic. So we have this thing called a frames reducer. We get the progress of the frames, and we know, whether or not we're complete. But as far as the display of the QR, it's different. Where's that? Yeah, I got the parser. Okay, QR loop. That's the little library we use.
The reason I asked is because it's the same, like many things are trying to solve the same problem. Like this is
Mm-hmm.
a universal problem to solve for it. Another one is like, they would mention like the screen quality. So like if my camera or the lighting can't read, then it could like deteriorate into like a worse quality one with bigger squares, but it's going to take longer time, but it's going to go through.
Right. Yeah.
Like lots of things to.
Yeah, it's another good idea. Yeah, so basically just how can we improve the communication between who's scanning and who's displaying the QR? Like, why not like establish a little channel between them and try to say, hey, I'm low light. Like, can you change?
We do it in person, like when we
Yeah.
we're like try to move it a little closer.
Right.
Or
Exactly.
turn up your screen display brightness, etc.
Exactly. And yeah, so that's something I would encourage people to look into. This is one of the friction points, and again, even with just Lightning invoices, like you get these awkward situations where you're like, oh, I can't quite get there. So yeah.
You ever play with seed timers?
Personally, no, I haven't. I've heard of it.
Pretty excellent experience. They have a little slider to dim and brighten.
Oh, nice.
As well.
Yeah, great. Yeah, stuff like that. It's only going to be more important with this animated QR because it's more data. Yeah.
So the cool thing about Piano is actually that the frames will never repeat. So like the more frames you scan, like at some point if you have enough of them, your probability of decoding the message goes up exponentially. Like it's a fault code that they use. And so you actually don't have to wait to come around to the same QR code that you missed. So that's pretty cool about it.
Yeah. I mean, I don't think we actually implement that feature of it.
The authors doing that. And we like it.
Yeah, I don't think. So I know we're using this to display, but I'm not. Actually, you might be right. Actually, let me double check this. So QR loop.
Yarn is generating the pieces of data, and then we're sending that to the yarn generator.
Yes, but there's no communication right now between the two. But yeah, I think you're right in the sense that, we should be. I guess we are using it on both sides. One, when we're parsing, and data to frames while we're displaying. So I'm sure these guys have thought about something like this. But yeah, I'm not sure. Yeah, I mean, they don't repeat. Maybe I'm misunderstanding this library. But I mean, you have a certain number of phrases, and it's going to go through. I don't see how out of the box you would just be able to kind of know what the other person's already scanned. Oh, I see what you mean. Okay, I got you. Cool. Yeah, anything else on this topic of animated QRs, ideas? Like nice looking or?
No, like dealing with, like it's such a pain every time. Like dealing with building it.
Yeah, I mean, you see.
So also like QR codes, if you tell people today, they're like, that's kind of like the payment system of the 2010s, not of the 2020s. So like, can we see Bluetooth, audio, NFC?
Right. Yep. Those are the other ideas that I'd like to explore more of. But yeah, anyways, animated QRs, cool stuff. So here's the fun part, I guess. Audio streams, something called frequency shift key encoding, frequency shift keying encoding scheme, roughly. And so we're dealing with binary data. This is basically how it works. You have ones and zeros, and you choose two different frequencies, one for the ones, one for the zeros, and then you put it on a carrier wave, and you end up with this clearly distinguishable, easily recognizable on the receiver side of a certain frequency for 1 and 0. And so you know, you just modulate quickly between them, and you should be able to pick up the data on the other side. So yeah, this is the thing I kind of wanted to demo, but we can get into it. We can also explore, I guess, I'm happy to just jump right into that and try to make it work, or at least I'll show you like the boring copy-paste version. But I kind of wanted to just like get it right in the app, like it's listening in and it just updates your balance. So if we want, we could use the rest of the time, the workshop time for that. And you know, we'll poke around the Fedi code base. We'll learn a little bit about kind of how things work there. And yeah, let me just see. Yeah, so if there's no other input on that, I think we'll just cover that. And I'll kind of walk you guys through what I was trying to do this morning. But let's see. Okay, so there's this library called quiet.js. That's over here. Right, so quiet.js is basically the library I found. And I was trying to get it working in React Native. Maybe I could just try it on web. That might be more promising because I was just running into Android build issues. But I'll show you their example. And let's see, maybe I can just do this from my phone actually. Where did I put that? Okay. Let's see how loud this is. So it sounds like that. Not great, but there's also an ultrasonic version. I'll play that next.
You gotta make it sound like the modems of the 90s.
Yeah.
Can you use this to scare off teenagers?
Potentially. It's like, take my money, run away. Yeah. Cool, yeah, so this little example app they've got. What's that? Let's see, so the Audible one here, so they have different profiles. So this quiet.js library, I'll pull up the profiles they're using. We can try and make sense of it together.
You're gonna have the same thing as with QR codes, where it'll be like, well, you need to speak up, and you need to go slow down, and you need to, depending on the quality of the audio, you'll have the same sort of like quality of it.
Yeah. Yeah, so this library actually uses something called GMSK, which is like, it's basically frequency modulation, but then you do like a Gaussian adjustment to it. So like, you just, you know, kind of smooth it out a little bit so it's easier to pick up if there's like interference. So yeah, these are the specs. If you look at the library, it's just, that's the Audible profile. There's a checksum scheme modulation, this frequency in the middle of the two that it tries to target. And then, yeah, some other parameters down here. And they've got a ton of other profiles, but that's the one that's on this website. And then the ultrasound sounds like this. Can't really hear it, but that's the point. But let's maybe try that one, the ultrasonic one. All right, so start ultrasonic receiver. Where's my mic? Where's the mic on the MacBook? That's not working. Let's try the Audible one. I think it's a little more reliable.
Scares off teenagers.
refresh the page actually. All right, come on, let's get an actual. I think it says 50%. Let's see. Huh.
Is the sound being firm routed somewhere?
Can you open your audio settings and check out what the volume is?
Yeah, I bet just this whole setup might be messing with it, because that was working pretty clean before. Let's try it one more time here. %50% or lower, okay. Okay, we got a little bit. All right, we got something. Let me replay it. A little bit of packet loss there. Yeah, it's pretty rough actually. I probably shouldn't be talking while it's trying to read it. I wonder where the mic is on the MacBook. So yeah, I mean, we can see, right? So packet loss, that's like kind of the frames of the QR code in a sense. We could only get 5 out of the 16. There might be more. So we didn't even get the full ecash note in here. I think we got the end of it. Let's see. And it's in segments, what's interesting. So this is all good. And it doesn't do it in pieces either. Or no, it does. I think it's concatenating. I'm just comparing it from what I see on my phone. So RZ, so this, it caught. This last bit is what I see on my transmission side, but then there's a missing piece, and then it picks back up. Yeah, so it's concatenating each of these frames together. You get the idea. It's just pieces getting transmitted through. And yeah, so maybe, I mean, let's see, if I'm trying to do this now and it's not working on the web, it's probably not going to work if I try to do it on the React native app. But we can poke around the code base anyways, just for fun. Okay, so let's see. QR code scanner. Let's get back. So I was just hacking around in here. QR code scanner. Was that it? No, what was it? QR screen. No. What is that? Scan. Omni scanner. That's the thing. So yeah, actually, this might be something cool to walk through. So we have a thing called the Omni scanner, and it's this clean little piece of clean little component that just like we scan so many things in the app: Lightning invoices, addresses, people's chat member QR codes, ecash. So we built a component that kind of is just like super flexible. We can put it on any screen we want and kind of just tell it what types of actions it can expect, what types of data. So this was the component I was starting to hack around with. I gave it this custom action just to add on. That's what you see down here. This extra little item. So we have paste. And then start listening would have been this kind of like, okay, if I can get this audio to stream through. But then the Omni input, and I'll just kind of show you the little parsing layers because it's interesting. The Omni input component, we base on the expected input types, we derive this just kind of Boolean as whether it can scan a certain data type. So LN URLs, LN URL withdraw, searching for chat users. And then the actions based off of whether you can search or not, we'll add it on. So we kind of have like this idea of a context depending on if you're looking at the top level QR scanner or if you're clicking the send button. And so like each time you see a scanner, we kind of like inform it with a certain amount of context so that it tries to kind of pick up on what the user's trying to scan. And even if like you're on the send Bitcoin scanner and then you scan a federation invite, it's like people might do that. Then we do kind of have a little pop-up we have here. Where would that be? Omni input, I believe. Oh yeah, that's in here. So where's that? Parse input, handle paste. What was this called? Props. Oh, Omni confirmation, actually. That's over here. So, yeah, so here. Oh, that's kind of hard to see. So depending on the type that you end up, basically after we detect, it's like, okay, this is the data that they're trying to parse with. This is kind of the contents of what that little confirmation window will be. So we picked up on LN URL pay. Hey, you're trying to pay a Lightning, an LN URL pay. This is the screen we send them to. We pipe the data through there. LN URL withdraw similarly. If it's a Fedimin invite, we go over to the join federation page. If it's a community invite, same, well, communities and federations are actually very similar. Ecash, that's gonna get you to this page where it is specifically for ecash. LN URL auth, you get the idea. So, so yeah, nice, just like a standardized interface for just anything and everything that we could possibly want to scan. We have kind of standardized code to say, this is what you should show in that content screen and what you're gonna do when the user wants to continue. And then the little icon that you want to show if it's unsupported, right? Okay, anyways, where was I? So we're coming back to the Omni scanner, and I'll just show you guys the parsing logic there as well. Where's that parser? So yeah, these are all the different types of data that we support in our Omni scanner. BIP21, some of them are actually unsupported right now, but we were preparing to support, for example, Bullet 12. We don't support yet, but we thought of it. We wanted, this was like, you know, a year and a half ago before it finally started rolling out. But yeah, so just some nice TypeScript interfaces for if we have an LN URL pay, what's the data that we expect to see in that type. BIP21, this is some of the old chat, the legacy chats code we were using, and then the actual parsing logic is in our utils. Here we define sort of certain things that you can parse before you join a federation. If you're doing a recovery, there's certain things you can't do yet. And actually, this is the top level function. So we have to imagine that they're gonna put in anything in there, whether it's pasting or scanning, and so we're running all parsers simultaneously, and whichever one resolves successfully first is what gets identified. So that's pretty cool there. And then, yeah, each individual parser's logic. Let's look at the ecash one just for fun. Parse Fedimin ecash. So yeah, like I mentioned before, validate ecash or validate notes is where we pipe that through. And this will end up returning, let's see what's in that data type, just the token. So yeah, we basically have a function, that's actually different than the one I showed you. Was it validate? Yeah, well, obviously, yeah, so you can give it any string, and if it's just not anything even remotely related to ecash, it's gonna error. But if it is, this interface actually might be different than the one in the web SDK, because this says it, wait, that's not the return type. This is, let's take a look at the return type on validate ecash. RPC ecash info. That type here, that does have the amount and the federation ID. So yeah, that's congruent with the other one. So okay, so then let's see here. All right, let me get back into trying to get this the audio listener going. So I got it to make a sound. Oh yeah, I was running into this issue with, let me find the right screen here, bear with me, screens. Was it here? Yeah, okay. So yeah, quiet.js, since it's not a React Native library, I found some guy who made a wrapper 4 years ago, but it didn't compile, and so I got it to compile, but now it doesn't have all the features. Like I can get it to send, like it can make a sound, but now I'm seeing that you guys can barely even hear that actually. Yeah, that's the, I can hear it, you guys can't hear that, but let's see, so if let's do this. So that approach, I don't know if it's gonna work without really messing with Android, but this other library, we can see the byte stream. Where did I put that? Start listening, live audio stream. Here it is. Okay, let's try that one instead. Okay, here's the, so yeah, I'll walk you guys through this approach, which didn't quite work out, but, or rather, it would have taken me a lot longer to figure out. But okay, so here we've got the logs, and wait, give it a sec to load up. And so, let me just walk you through the code a little bit. Permissions, once they're granted, we set up a listener for this live audio stream library, which does seem to actually pick up my audio from my MacBook. And so we get a stream of data, we decode it from base 64, and then I'll just kind of show you guys what it looks like. If I try, let me stop it as soon as I see the first one, just so our log doesn't blow up. All right, so go over here, start listening. Okay, let me log more of that actually, sorry. Let's log the full set of data, undecoded, just raw, and then straight decoded like that. And yeah, I was just trying to analyze kind of what was in there. And the parameters I give it actually, I was trying to think of, so the buffer size, I was trying to match it to what Quiet.js said they were using. Buffer, what was it now? It has it in here somewhere. Speaker, maybe in the example. I forget where they put it. Speaker transmissions of profile transmits around the 19 kilohertz range. So yeah, I couldn't figure out how to specify frequencies. I'm pretty sure I had to I basically had to build a DSP module getting this raw. Let me just show you what it looks like. So data decoded. Let's hide this for now. There it is. Okay. Let's get this out of my. Oh, that's actually quite a lot. Oh, there it is. Okay. Okay, so you can see. Sorry, let me just copy this out of this tiny window. It's actually going to be difficult without a mouse. No. Select end position. I've never tried that. Oh, nice. I didn't know I could do that. Let's get all the way down. Okay, so that's the raw data. We also get the decoded data. Oh shit. Bear with me here. Yeah, it's a really cool tool called mprox, but it has its quirks. It lets you, yeah, I mean, you see all these processes on the left. Really convenient when you have lots of those, but okay. New window. Let's format this thing. Let's pretend like it's JSON. And then format. All right. Ooh, what do we got here? Okay. Okay, didn't format obviously the raw data, but you can kind of see that it's binary. It might even have slash delimiters or something like that. These are just zeros, I believe. And then, yeah, so this, I realized it was giving me, yeah, it's basically one element in the array for every buffer. So that if I make this a 1, let's do 10, tiny little buffer. And this actually, so the sample rate might have something to do with this. Let's play around with this a little bit. So bits per sample. Let's try that. Just so we don't have to parse through so much logs. Uh-oh, invalid sample rate. That makes sense. Gotta be a power of 2 probably. Is it just too low maybe? Let's give this a multiple. Just trying to kind of make things smaller so it's easier to analyze. Okay. Still, okay, a little less data, but yeah. So I think what we're seeing here is like just a raw waveform. I don't even know like where to begin, like if it's some kind of baseline or like how I can even go from this to like, okay, there's a frequency modulated wave in here that I'm looking for. So yeah, like I said, didn't have the full demo ready, but I got as far as this and I was like, okay, well, how do we even parse this stuff? There's obviously libraries for this. And so I think what I'll maybe do for the hackathon is just figure out how to get this quiet.js React Native library working, because somebody did plug into it. It just didn't really, I couldn't get the receiver to work. It was supposed to be, this little listener is supposed to be giving me the message in the profile that I expect it to be, so that if I play it from the same library over here, it pops up over there. So yeah, I don't think we'll debug this together, but yeah, I'll leave it there. Maybe, let's see, we got on time. We got like 15 minutes. What I could do with the remaining time is go into the structure of some of the cashew stuff. Just thought that was interesting. But yeah, if there's no other questions or other topics, yeah, go ahead.
Do you think, what's your opinion on like the UX feature of like sound-based?
Oh, I think it's terrible. But it's fun. I don't know. It's like kind of, proof of concept type of thing. But honestly, what's more interesting, more practical is, what is it, Bluetooth or NFC? Even like like how can you just need to send data between two phones. So is Bluetooth secure enough for that? Is it, customizable enough for that? Maybe I have to look into it. But yeah, I don't think audio is the way to go, to be honest. Yeah.
You can have ecash tokens on the tape.
Yeah, actually, well, yeah, I mean, there's creative ideas, right? If you're talking about user experience, efficiency, just trying to get from A to B, probably not. But yeah, I mean, I think there could be cool, just like, okay, you're broadcasting waves and you can be spraying money out during a concert, and like, you just got to be listening into the right frequency. It's like, just kind of scavenger hunt ideas, I guess, like that. Yeah. Yeah, so it's fun more than anything, but user experience-wise, I don't think this is the direction. Yeah, Morse. Okay, so yeah, last piece here that I thought was interesting. Or no. Yeah. Oh yeah, if any of ones have been scanning this, that's mainnet ecash, by the way, if anyone noticed. Yeah, I'll leave this up for a bit if anyone wants to claim that. But hurry up. Maybe I messed up then. Oh, right, you don't have the, I think it was Bitcoin principles, so. All right, here, okay, yes, this is what I found. All right. Oh, that's not it.
Yes, I mean, it's not the federation that we fix. The federation that you choose, so they can automatically choose the right federation after the fact. Yeah, we might not do it.
Where is this? All right, here we go. V1 keys. So Cashew has a nice little spec here. Not for the keys. Over here. Okay, so last thing here, guys, real quick. So Cashew has an API for the keys, which are basically the denominations here. So when you generate the key material that you want your note to be composed of, you do that from your own seed first, but then you need a signature from the federation. And so you use these keys to combine it with your key material before you send it to the federation so that you can unblind it later. And so if you look at any mint, for example, this one, at least a Cashew mint, there's a nice little API for this, v1/keys, and this will tell you everything that you need in all the denominations, right, all the way up to however much it supports. And so, yeah, your client needs to use this key in order to generate the ecash. So, yeah, I think I'll leave it there, guys. Thanks for watching. And I'll close off here at my end of the slide. Definitely check out the source code, the repo we have. Check out the Fedimint Web SDK. And we are hiring. There's some open positions. Let me blow that up actually here. There's 2 engineering roles we're hiring for if you want to come help us out, build the kind of best user experience for ecash that we can possibly make. Yeah, we're hiring. So thanks for watching, and have a great rest of the conference.